Welcome to the dialogue. You know, there's something truly captivating about Mars, isn't there? It's the red planet, our cosmic neighbor, and people have looked up for centuries, just wondering what's really going on up there. Today, we're diving deep into India's incredible journey to Mars. It's a fascinating story. We'll explore how India didn't just, join the Mars Club, but how they're actually redefining what's possible in space, showing a new way forward, really.
Absolutely, and we're excited to guide you through this. We've pulled together quite a bit of information for our chat today. We're aiming to give you real insights into India's technological wins, their scientific discoveries, and the ripple effect this whole endeavor has had globally. This deep dive, it's really about uncovering the how and the why behind India's success, and importantly, their vision for Mars's future.
Right. And the goal isn't just, listing facts. We want to understand the implications. What does India's approach actually mean for space exploration? By the end of this, you'll hopefully have uncovered some surprising details, maybe some profound thoughts about Mars, and you'll definitely feel well informed. Perhaps even spark a bit more curiosity about space yourself. So yeah, let's get into this amazing story. Okay, so let's start where it all began, India's historic leap to Mars and the legacy of MOM, the Mars Orbiter mission. I mean, the first thing that jumps out is that incredible achievement, reaching Martian orbit on the very first try. That's exceptionally rare, isn't it? Even the space giants didn't pull that off initially.
It really is remarkable. That's where you see India's unique approach, sometimes called frugal engineering, really pay off. So the Mars Orbiter mission, or Mangalyaan MOM, launched back in 2015 by ISRO, the Indian Space Research Organization. Their strategy wasn't about inventing everything from scratch with the absolute latest tech. Instead, they were very smart about it. They focused on using proven, reliable technologies, maybe off-the-shelf components where possible, combine that with incredibly rigorous testing and a very streamlined design.
Which sounds like a good way to minimize risk, especially for a first interplanetary attempt.
Exactly. It minimized risks and dramatically cut costs. This was kind of a paradigm shift, proving you could do complex interplanetary missions without the absolutely massive budgets people often assumed were necessary. And boom, MOM's success instantly made India the first nation in Asia and only the fourth space agency overall to orbit Mars. That's joining a very elite club right out of the gate. It fundamentally challenged assumptions about deep space exploration costs.
And it didn't just get there. What's maybe even more impressive is how long MOM lasted. It blew past all expectations, didn't it?
Yeah.
Designed for maybe 6 months, and it operated for over 8 years. That's incredible performance.
It really is. And that longevity, it wasn't just like a lucky bonus. It was a serious demonstration of India's capability. Managing a spacecraft, keeping it operational in that harsh, distant environment for so long. It requires sophisticated automation and autonomy. The spacecraft had to handle things itself. Light delays mean you can't just joystick it from Earth. So it needed to self-correct, adapt.
Right, you can't fix it in real time.
Precisely. And MOM's ability to do that for 8 years, it subtly rewrote the thinking on long-duration missions. It showed the power of building robust, autonomous systems. This experience is invaluable as we plan longer, more complex journeys, perhaps further out into the solar system. Those improvements in long-term operation and self-reliance are crucial.
Okay, so building on that success, India isn't just resting on its laurels. We're hearing about MOM 2.0, Mangalyaan 2, and this sounds like a really ambitious follow-up, poised to be bigger, bolder than the first one. The exciting part, they're planning not just an orbiter, but a lander, and get this, a Martian helicopter, for the first time for India.
Mm-hmm. A lander and a helicopter. That's a significant jump in complexity.
It really is. Landing on Mars is notoriously difficult, right? 7 minutes of terror and all that. And then operating a helicopter in that thin atmosphere. What gives ISRO the confidence they can tackle this, especially given their typically cost-conscious approach?
That's the key question. I think their confidence stems from two things. The solid foundation built with MOM-1 and their step-by-step approach. The first mission proved they could operate reliably around Mars. The logical next step for deeper science is getting to the surface. The helicopter idea, yes, it's clearly inspired by NASA's Ingenuity. Ingenuity showed it's possible and scientifically valuable.
A technology demonstrator that really worked.
Exactly. And ISRO hasn't been idle. They've been developing and refining their own landing systems, robotics, miniaturization for years now. Landing is hard, no doubt. But ISRO has a track record of finding innovative solutions to tough problems. So MOM-2, it's not just another orbiter. It's about putting boots, robotic boots, on the ground. And if that helicopter flies, India becomes only the second country ever to achieve aerial exploration on another planet. That's huge.
Okay, let's shift back to the science from the first MOM. That incredible longevity must have allowed for some serious data gathering. What were some of the key discoveries? Talk to us about the evidence for ancient water systems.
Right. So MOM contributed significantly to painting a picture of Mars' past. Its Mars color camera delivered these just stunningly detailed images, high-resolution views of craters, vast valley networks, features that look very much like ancient lake beds, paleo lakes. At the same time, you had instruments like the thermal spectrometers mapping the surface composition. They detected clays and other hydrated minerals, types of minerals that typically form in the presence of water.
So combining the pictures with the mineral maps gives a stronger case.
Precisely. You see the landforms that look like they were carved by water, and then you find the mineral evidence that water was indeed present. It really strengthens the argument for ancient habitability. It points towards a time billions of years ago when Mars could have been, well, a much wetter, possibly more life-friendly planet. It's a profound insight.
And sticking with potentially life-related signs, MOM made waves with atmospheric discoveries too, particularly methane. Why is methane such a big deal?
Methane is, it's a hot topic because it's considered a potential biosignature. Here on Earth, a significant amount of methane comes from living organisms. Now, it can also be produced by geological processes, so it's not definitive proof of life.
Yeah.
But finding it on Mars is incredibly intriguing. MOM had instruments capable of monitoring methane levels in the thin Martian atmosphere. It tracked how concentrations changed over time and in different locations.
So it wasn't just a one-off detection.
No, exactly. It observed variations, dynamics, and this data, it really energized the whole debate about Martian biology. It spurred international research efforts trying to pin down where this methane is coming from. Is it geology happening today? Or could it be biology? It's one of the key questions driving current and future Mars exploration. Does Mars harbor life now, or did it recently?
Fascinating. And MOM2 is set to push this even further, right? Getting beneath the surface, essentially. With new instruments like energetic ion spectrometers and radio occultation experiments. What will those tell us?
Yes, MON2 aims to build directly on MOM1's findings, but go deeper. The energetic ion spectrometers, for example, will study charged particles high in the atmosphere. This helps us understand how the Martian atmosphere interacts with the solar wind and how it's been lost to space over billions of years. That's crucial for the habitability story. And the radio occultation experiments, they're clever. They send radio signals from the orbiter that pass through the atmosphere to Earth. By analyzing how those signals bend and change, you can map the atmosphere's density, temperature, and structure very precisely.
And that hints at the subsurface.
It can, yes. These techniques can sometimes detect subtle variations that might indicate layers of ice or even liquid water hidden beneath the ground. So understanding that subsurface structure, finding potential ice deposits, it's vital for two big reasons. One, it helps reconstruct Mars's climate history, how it went from potentially wet to the cold desert we see. And two, looking ahead, buried ice represents a critical resource, especially water, for any future human missions or outposts. We need to know where it is.
That makes perfect sense.
Okay.
But this naturally leads us to the broader impact, the global ripple effect of what ISRO is doing. India's approach hasn't just yielded science, it seems to have influenced the whole global space community. I remember hearing that comparison, the entire manned mission cost less than the movie Gravity. Is that, actually true? And how is that even possible?
Yeah, that comparison catches the attention. While it's a simplification, the core point is absolutely valid. ISRO has genuinely pioneered an extremely cost-effective model for planetary exploration. A big part of it is their open approach. They're proactive about sharing their data, which encourages international collaboration. They haven't kept it all close to the chest. And this whole package, the low cost, the success, the data sharing it, sets a new benchmark. It shows other countries, maybe especially emerging space nations, that high-impact interplanetary science is achievable without breaking the bank.
So it's inspirational, showing it can be done differently.
Definitely. It demonstrates that you don't necessarily need the budgets of NASA or ESA to make significant contributions. Plus, their data and the models they build from it, they serve as valuable independent points of comparison. They help validate or sometimes challenge the models from other agencies. It fosters a healthier, more robust global scientific understanding of Mars. It's not about cutting corners, it's about smart engineering, efficiency, and leveraging homegrown talent and tech.
It really is inspiring, and it connects directly to the idea of paving the way for human missions. These aren't just robotic advancements in isolation, are they? Things like better autonomy, navigation, making instruments smaller. How do these help the human exploration goal?
They're absolutely critical building blocks. Think about it. Robotic autonomy is essential when you have those light travel time delays. A rover or lander on Mars needs to make some decisions on its own, react to unexpected situations without waiting for instructions from Earth. ISRO's work advances that. Sophisticated navigation ensures you can land precisely where you want to, perhaps near interesting geological features or resources. And miniaturization is huge. Smaller, lighter instruments mean you can pack more science onto a single mission or use smaller, less expensive
Right.
rockets.
Reducing mass is always key in spaceflight.
Always. And ISRO's contributions go beyond just the robotics. Memofoom provided valuable data on the radiation environment between Earth and Mars and on the Martian surface. Understanding that radiation is absolutely paramount for astronaut safety on long journeys and during surface days. They've also gathered crucial data on the atmosphere, dust storms, weather patterns, which you need to know for planning safe surface operations and designing habitats. All this feeds into making human missions feasible and sustainable.
It's almost like a counter-narrative in space exploration, that you can achieve world-class results affordably.
It really is. India's Mars program proves that strategic investment, coupled with genuine ingenuity and a different way of thinking, yields top-tier science and, frankly, global prestige. And it does it for a fraction of what used to be considered the standard cost. That's a powerful message. And, to make sure this science isn't just stuck in academic papers, ISRO has also been good at using things like sophisticated data visualization, creating 3D terrain models from their data. That helps scientists piece together complex puzzles like how Mars lost its atmosphere, or how surface features formed, or how the climate evolved. But it also makes the discoveries more accessible, more understandable for everyone.
Okay, looking forward then. What are the next steps? What does the future hold for India's vision for Mars? We mentioned MOM-2, hopefully launching before 2026 with its lander and helicopter and advanced instruments. But what about beyond MOM-2? What are the longer-term ambitions?
The vision extends well beyond MOM-2. India is thinking comprehensively about sustained Mars exploration. There are conceptual plans and likely development work underway for more advanced landers, more capable rovers exploring further afield. And really excitingly, they're looking seriously at in-situ resource utilization ISRU technologies. Things like demonstrating the ability to extract oxygen from the thin Martian atmosphere, which is mostly carbon dioxide.
Wow, like the On-X-I experiment on NASA's Perseverance rover.
Exactly like that concept. Proving you can live off the land is fundamental for sustainable human presence. If you can make your own oxygen for breathing or potentially for rocket propellant to return home, that dramatically reduces the mass you need to launch from Earth. So all these efforts, orbiters, landers, rovers, ISRU, they're logical steps on a path towards eventually supporting human exploration and maybe even outposts on Mars.
And this isn't happening in a vacuum. India seems committed to working with others, right? Expanding international partnerships with NASA, other agencies.
Yes, very much so. Collaboration is a key theme. They've had successful collaborations in the past, sharing data, sometimes carrying instruments for other agencies. Building on those successes opens up even more possibilities for shared deep space missions, comparing data from different instruments, cross-calibrating results, maybe even joint missions down the line. It's a recognition that exploring Mars, understanding it fully, maybe one day sending humans there. It's such a monumental task, no single nation can or probably should do it all alone.
It benefits everyone to pool resources and knowledge.
Absolutely. It speeds up discovery, avoids duplicating effort, helps manage the immense costs and risks involved. So when you look at India's Mars program overall, you see this very systematic, step-by-step progression. Each mission builds on the last, increasing capability, deepening scientific understanding. It's all contributing to that shared human goal. Figuring out Mars, and maybe, just maybe, one day making it a second home. India isn't just boosting its own space program here, it's genuinely helping to reshape how the entire world thinks about and executes interplanetary exploration.
What an incredible arc. From that audacious first success with MOM to these ambitious forward-looking plans involving landers, helicopters, resource utilization. India's journey to Mars really underscores how one nation's ingenuity, their strategic focus and innovative spirit can genuinely shift the landscape of global science and expand our cosmic horizons. It's quite something to reflect on.
It really is. And perhaps, thinking about all these advancements we've discussed, it leads to a bigger question for all of us. Given everything we're learning and developing, what do you think is the single biggest challenge or maybe the biggest opportunity we need to tackle to make Mars a truly viable second home for humanity? Something to ponder.
That's a fantastic question to leave everyone with. What stood out most to you listening today about India's Mars story? Was it the frugal innovation, the first try success, the future plans. We really encourage you to chew on that, maybe share your thoughts with others, keep exploring these topics. There's always more to learn. Till next time on Dialogue, keep looking up.